Okay, students, go ahead and go through a few of these here. We're solving quadratic equations by graphing. Okay, so first quadratic equation. This is called the standard form of a quadratic equation because it goes from the highest degree down. This is degree 2, degree 1, degree 0, because I can write that as cx to the 0. The degree of each term, remember terms are separated by plus and minus signs. The degree of each term is the sum of the exponents on the variables. Now you need to understand that a is not a variable. A is a coefficient of the variable x, b is a coefficient of x, and c is a constant, just a number. So this is called, when it's degree 2, that's called, if they're all of a same variable x, for example, that's called a quadratic polynomial. It's quadratic because the highest degree of any of the terms is 2, okay? And that means a cannot be 0, which it says right here, because otherwise if it was 0, it'd be down to degree 1. Okay, so this is basic vocab that you're supposed to know. You should have learned this in Algebra 1. So this is called the quadratic term, because the degree 2 term. This is the linear term. And this one is called the constant term. Okay, so the quadratic term is going to determine the shape of the quadratic. Okay, so this, whatever this ax squared is, that's going to determine the shape of the quadratic, how wide or narrow that u is, whether it opens up or down. If a is positive, it opens up. If a is negative, it opens down. Okay, so a positive opens up. A negative opens down. Okay. The closer the number is to 0, the wider it is. The further away the a is from 0, the narrower it is. Okay? Just so you know that. The general shape. If there's a bx term, that shifts it right or left from its origin. When the quadratic goes to the origin, that's called, where the vertex is at the origin, I should say, not when it goes to the origin. The vertex at the origin, this down here is called the vertex. Well, that's at the origin, that's called a parent function. If it's ever shifted away from the origin, as it is in this case, it's no longer a parent function. What makes it shift left and right is if there's a bx. What shifts it up or down is if there's a c as well, okay? Other than 0. That will shift it up and down. Okay, just so you know how these things are being affected here, okay? So if I just had an ax squared graph, that has a parent function that's going to start at 0, 0, the origin. Okay, if there's no linear term, there's just a c term with the ax squared, then it's going to shift it up or down from the origin, so it'll be still on the y-axis. But if there's a bx term where b is not 0, then it's going to shift it left or right. All right. So solving it, there are multiple vocab words. 3 of the 4 are listed right here. One of the vocab words for solving a quadratic is roots. Find the roots. Another one is find the solutions. Another one is called find the zeros. They all mean the same thing. The last one would be the x-intercepts. Those are all x-intercepts, where that means where it crosses the x-axis. So in this case, those are the solutions right there, 2 and -3. Okay, so that's what we're solving for. Try to find where it crosses the x-axis. Also called zeros, solutions, or roots. You need to know all those vocab words. All right, so that takes care of vocab-wise and how the equation gets shifted. Okay, so now let's go ahead and look at this example here. Solve this quadratic by graphing. Well, since there's a plus x, it's going to shift it left to right, and since there's minus 6, it's going to shift it up or down as well. Okay. The general shape of the graph is y equals x squared. Okay. Now, the x coordinate of the vertex, remember this is the vertex right here. The x coordinate is always solved by doing negative b over 2a. Remember, a here is 1, b is 1, and c is negative 6. So negative b puts it at negative 1 over 2 times 1 is 2. So negative 1/2 is the x coordinate of the vertex. That's the x coordinate. To find the y coordinate, I would plug that negative 1/2 in, okay, to the x. If you're doing it by hand, you got to deal with some fractions. Negative 1/2 squared is 1/4. Plus x would be negative 1/2 and minus 6. 1/4 minus 1/2 is negative 1/4. Minus 6 is negative 6 to 1/4, or negative 6.25. Okay. So this point is negative 1/2, comma, negative 6.25, or 1/4. That's the vertex. Now, how do we know it opens up? Because A is positive. Remember, we had this over here. So we know it's going to open up. Now, they're having you make a table of values. Okay, so we're doing it by hand. Of course, you can put all this in graphic calculator, do it all for you. But here's what I want you to learn. This is how I teach it. Is we're not going to make a table of values. Okay, we're going to use the general shape of the graph and do an XYT chart from the vertex. That's like the new 0, 0 right there. So I make an XYT chart. I plug in 1, and that is into y equals x squared, because remember, that's the shape of the graph. We've already taken care of the plus x and minus 6. That's what shifted it left 1/2 and down 6.25. The shape of the graph is just the ax squared part right here. So y equals x squared. So if I plug in 1 for x, I get 1 for y. So that means if I go right 1, I'm going to go up 1. Okay, so right 1 puts it right there at 1/2, and up 1 is negative 5.25 right there. Okay, if I go right 2, I'm going up 4. And same thing with negative 1, 1, and negative 2, positive 4. Okay, so if I go right 2, 1, 2, now I'm going up 4. 1, 2, 3. Let's see. 1, 2, 3, 4 right there. And left 2, 1, 2, up 4 right there. Okay, so you see I am getting the general shape of the graph. It's landing right on this right here. Okay, now since this, if I go right 3, for example, and up 9, and left 3, up 9, it would make the graph go through the negative 2, negative 3, and the positive 2, but it's not going to land right on it. So the other way is to factor that. First off, I would see, so it says solve by graphing. I would actually solve by factoring in this case first. I'm going to first see if this factors. This does factor nicely into x plus 3, x minus 2. Okay, so that's telling me right there that the roots are negative 3 and 2. So I could actually already put it negative 3 and 2 right there. Okay, because you said each one equal to 0 and solve, so that gives me x equals negative 3 and x equals 2. That's those 2 points. Quote by graphing, I could go ahead then in do the negative b over 2a to get the vertex of negative 1/2, negative 6.25, and just graph a curve that goes right through there. Okay, solving by graphing is the least nice way, unless you're going to use a graphing calculator. Okay, factoring or quadratic formula much quicker than solving it by hand, doing it by hand, unless the actual, when I graphed it, it actually landed right on it using this right here, okay? Using my general shape y equals x squared, okay? So the first thing I'll be checking is see if it factors. I see you have your two answers. Now that since you're asking to solve by graphing, you can't stop there. You got to go ahead and do the vertex at least, and then draw your U shape. Negative b over 2a, and then connect it. Okay, let's go ahead and look at the next page. Solid quadratics by graphing again. Okay, this time by the, if exact roots cannot be found, state the consecutive integers between which the roots are located. So again, my general shape is y equals x squared. It's telling me it's going to shift left or right and up or down as well. So it's not the origin, so it's not a parent function. Negative b over 2a gives me 2 over 2, which equals 1 for the x coordinate. And plug that in. 1 minus 2 is negative 1. Minus 2 is negative 3. So 1, negative 3 is the vertex. And there you see right there. Okay. Again, now using my shape, general shape is y equals x squared. So that means right 1, up 1, left 1, up 1, right 2, up 4, 1, 2, 3, 4. Left 2, up 4 right there. So now I have the general shape, and it goes between, it says if it's not exact, state the consecutive integers. Consecutive means one after the other. So it's between 0 and negative 1, and between 2 and 3. There's where your two roots are. Okay. We'll see coming up, I guess, if we will solve it by completing the square as well. We can also use quadratic formula. Quadratic formula give exact answers that would have radicals involved in it. Here, they're just asking for estimation. Again, you could get these answers, all this on the graphing calculator, but the point is for it to work on doing it by hand. Okay, so you really understand how to do it instead of just plugging things in the graphing calculator. All right, that goes ahead and answers these questions here.